All right. Typically for a gas station, they'll have a tank in the ground that's a cylinder on its side, right? Kind of a barrel that's tipped over. And I think I drew that a little bit too small, so I'm going to flip this paper over and draw it a little bit larger so that we can see what's going on there. So, a barrel on its side. You got a picture of that? And they'll put a pipe down to the bottom of the tank. The pump will have to lift it to the ground and then up to the service station stand where you grab your hose and take it out. So the pump has got to lift it up to there. Now I know it pressurizes it and does more than just lift it there, but let's just talk about the work lifting the fuel from the tank up to there. And let's just say the tank is half full of gasoline. So now it's gasoline. Let's color that purple. Okay, half full. Let's say the tank is got a radius of, let's say 6 feet, and it's 15 foot long. All right. So we're going to be lifting gasoline up to there. So I'm going to take a slice, a representative slice. And now to define what that slice is I have to find its weight density. Well, water's weight density, let's put it in pounds per foot because I'm in feet here. Water density is 62.4. Gas is about 3/4 of the weight of water. It's 75% of that. So roughly 3/4 of 60 would be, I don't know, let's just call it 50 pounds per cubic foot. So the weight density of the liquid, we'll just call it liquid so I don't have to be held to it's really gas, but that's what I'm going to say. And let's say it's about 50. I could figure it out more exact, but we'll just call it 50 pounds per cubic foot. So next I have to decide where my coordinate system is going to be. And for ease, this is the one that you really don't want to be as free about where you're going to put your coordinate system. I'm going to put the coordinate system through the center of the tank. You'll be much better off if you do. So I'm going to call the x-axis there, and I'm lifting it up here. I'm going to call this the y, and that's what we're going to work with. And I'm going to actually make the positive y down here. It's not going to really matter a whole lot, but you'll see how this works. Okay. So I have a coordinate system. So now I've got to do the work. So I've got weight density of 50 pounds per foot cube, but work's got to be just the pounds, so I got to get the volume. And the volume of what I'm lifting is this red shaped thing. Its thickness is going to be in the y direction here, so it's going to be dy. Its dimensions are going to be, well, from here to someplace on this tank. That would be a point in x, y, so this would be over x. So this side is d2xy, dy thick, 2x wide, and 15 long. The length is not going to change. So the volume of this disk that I need to take times this is going to be 2x times 15 times the thickness dy. Length times width times height. Length 15 times width 2x times height dy. There's the volume. That's going to cancel the feet cubed, and I'm going to be left with pounds, which is a weight. That's why I call the weight density. And that's the weight, the force that I have to lift to the top. And to lift it, I got to lift it, let's see, how high was this? Well, if it's 3 feet under the ground and maybe 5 feet to where the hose comes out, or maybe it's 6 feet, I have to lift it 9 feet plus the distance of the tank, which is 6 feet. That would be how high I have to lift this part. This part's going to be this much more distance, which, if that's the origin, this is y. So I'm going to have to lift it 6 plus 3 plus 6 plus y is how far I've got to lift that chunk of gas. So it's going to be the force, the weight force, times the distance, which is 15 plus y. And that's for just this slice. I got to do all the slices here. And so I'm going to add up the work for doing all those slices. This is the distance. This is the force, force times distance. And I got to do it for y going from 0, so it's just 15 that I got to lift it, all the way to y going out here to 6. And that would be my integral. And I could do it if I didn't have the problem of it being dy and that being x. Now, how do I get an expression for x, this distance? Well, that's why I put the coordinate system in the center. Because, as you know, this is the radius, but so is this. This is y, this is x, that's the radius of 6. Pythagorean theorem says x squared plus y squared would have to equal 6 squared. So x would equal 36 minus y squared square root, solving for the x. So that's what I'd have to put in for the x. This. The constants could pull out, but you could also just type this in like this with that in place of the x and evaluate from 0 to 6. And I'll get the work to pump out the bottom part of the tank.